So, good morning to all. Today, we are going to start a new topic entitled signal flow graph. Okay. So, what is the signal flow graph? First of all, we will understand it. Now, so first of all, we have to understand that what the signal flow graph is. Okay. Till date, we have learned about the block diagram reduction technique. So what we have done with the block diagram reduction technique, that we were having a system which is consisting of many subsystems which are being represented by blocks. Each block has its own transfer function. Then there was a block, there were not only feed forward path, there were feedback path also there. Some blocks connected in cascade, some in parallel. Okay, likewise, this you have a complex block system is there. Okay, then what was your task? The task was to reduce to a single block. This whole complicated block diagram, you have to reduce it to a single block. Okay, and for that purpose, you have utilized the different techniques of the block diagram reduction. Okay, that when they are in cascade, what will be the net equivalent? But then they're parallel, when we have to move a summing point ahead or beyond a block, the takeoff point ahead and beyond a block, like this way. Today, we are going to go for another method which is called as a signal flow graph. This is also for finding out the transfer function of the system. Okay, but now the system will not be represented by a block but by a graph. Okay, it will be a graph. Graph means certain lines will be there, some arrow will be there. Okay, and now we have to reduce this graph to a single system, to a single transfer function, that is CS by RS of the overall system. Okay, so these points will be covered today: the introduction to signal flow graph, definition, then what are the terms which is being used in a signal flow graph. Okay, and then what is the signal flow graph model, then how to reduce a block diagram. BD means block diagram to signal flow graph. Then we will take some examples, and then the most important thing which is related to the signal flow graph is Mason gain formula, an example related to it. Okay, so today is this much we will have to cover it. Okay, so with the assumption that there's no problem in the block diagram reduction technique, if demand will be there, we will take more numericals related to the block diagram reduction technique. Okay, but I will be proceeding to the new topics if there is a no question or no query is being there. Okay, if query is there from your side, sir, please take some more numericals. Definitely, I will take some more numericals on block diagram, also on signal flow graph only. Otherwise, I will assume that whatever matter I have given, okay, the students are understanding it completely. Now, so once again, many of them have joined it. So thank you very much for greeting me for Happy Teachers Day. Okay, many of your participants have greeted me Happy Teachers Day. So really, it is a joy for me that today my students are wishing me. Okay, so let us move further. So first of all, in the introduction, let's have a definition. Okay, so through definition, it should be clear that what is the signal flow graph. Now you are going through three words: signal, flow, and graph. So signal is there, flow is there, graph is there. So what happens in a system? Okay, what happens in a system? In a system, you apply input. Input create a signal. Okay, and that signal traverses to the different subsystem, and ultimately you are getting an output. Okay, so basically in a system, what is happening? Signal is flowing. Okay, now if you represent the signal flow in a graphical way, then the graphs obtained, then the diagrams obtained is called the signal flow graph. So the definition of a signal flow graph is very simple. It is a graphical representation of the relationship between variables of a set of a linear algebraic equation. Okay, basically this was a mathematical approach given by Mason. Okay, it was given by Mason. Okay, where what he did, that he tried to express the linear algebraic equation through graph. That is a very innovative idea he put forward. Okay, that he is put linear algebraic equation in the form of graph. So far, you have seen the mathematical form of linear equation like 2x plus 3y is equal to 2. Now, what he did, he represented it by in a graphical form. Okay, particularly establishing the relationship between variables involved in it. For example, 2x plus 3y is equal to 2. So x and y are the two variables. How they are being connected, that is being represented graphically. So that is known as a signal flow graph. So this is the beautiful definition of signal flow graph. That a signal flow graph is a graphical representation of relationship between variables of a set of a linear algebraic equation. Okay. Now, this is the definition is very clear. So in our block diagram also, since we use the Laplace transform, okay, each block is being represented by a transfer function, and the transfer function is nothing is being expressed in the Laplace transform. And Laplace transform do what a wonderful thing that it convert differential equation into algebraic equation. Hence, the same signal flow graph can be applicable to our so-called the linear algebraic equation also. So it is a graphical representation. You have to keep in mind first of all, and what it did, it do relationship between variables of a set of a linear algebra. What are the variables involved in it? So establish a relationship between them through graph, not by equation. Equation is there, but from that graph we draw the from that equation we draw the graph that it depicts that yes, it is establishing a relation between the variables. Now, what it consists of? Okay, so signal flow graph consists of network in which nodes are connected by directed branches. So nodes are there. Okay, what are nodes? Nodes are simply nothing but some points like this nodes, like this node, like this node. Okay, and these node will be like this nodes. Okay, so if I connect this node by these lines, then this will become branch. This will become similarly like this. I connect it and I connect like this. Okay, and I have to put a direction. Direction will indicate that my signal is moving in which direction. Okay, so these are the different nodes. This is one node. Okay, this is second node, and this is a third node. The same node concept which you have learned in your circuit theory. Okay, where two or more than branches meet, okay, a node is formed. Okay, so here also you have node. The node represent the variables of the system. The node represent the variable of the system. Say example, three variables are there in a system. So first node is x1. Okay, second node will become x2. Okay, and the third will become x3. So means three variables x1, x2, x3 are there, which are representing the system. Okay, so they are will be represented by nodes in a signal flow graph, and they will be connected by a straight line which is called branch, and each branch will have an arrow sign. The arrow will indicate that how signal is moving. For example, in this case, let's say in this case, the signal is moving from x1 to x2, not from x2 to x1, because the arrow is in this direction. Is it clear? Is it clear? What is the node is there? So, in fact, it depicts the flow of signal from one point of a system to another, and thus establish a relationship between the signals. Okay. So what happens? This is x1, this is x2. The branch is there with arrow sign. So it indicates that signal is moving from x1 to x2. Similarly here, this is x2, this is x3. What and the arrow direction is this much. So what inference you are getting? The signal is moving from x2 variable to x3. Okay, and in this case, the signal third case x1, the signal is moving from x1 to x3. So through graph, it is very clear how signal is traversing. Okay. Okay. So now after going through the node and branch and the direction, let's now come to the fundamentals. Okay. So to understand it through an equation, because I have already given you the definition that in fact the signal flow graph was first of all used to represent a linear algebraic equation in a graphical form, establishing the relationship between the variables. Now say, let us take a very simple equation, y is equal to ax. Okay. You all have drawn this equation okay, in the form of a straight line passing through origin in a Cartesian coordinate system. I think so. You remember, you have did in your lower classes. Am I correct? Am I correct or not? Okay, so I have an equation. Okay, y is equal to ax. Now I have to represent it graphically by signal flow graph. So how many variables are there? First of all, find out how many variables are there. Okay, there are two variables are there. What are they? X and y. So y is an dependent variable and x is an independent variable. It is very clear. Okay, so what this equation represent? The signal y is equal to a times the x. A times the x. So what I would, so two variables are there. So how many nodes? Then in fact I have told you that the number of the nodes is being decided by number of variables in the system. Okay, two variables are there. Okay, so how many nodes? Please write in the chat box. Everybody should write down that how many nodes will be there in this equation y is equal to ax. Yes, some people are writing. Okay, very good, very good. Okay, correct. Okay, fine, correct. Good, good, good. Yes, good. So there are two nodes are there. One is representing x and another is y. So these are the two nodes. You can see, though I have represented here, but you will write here only. Okay. So two nodes. One is this, and another is this. Okay. So the first one will be assigned x because y is dependent upon x. So I will first of all write down a x. Now this x is connected to y, okay, through a branch, and the arrow, this arrow will be marked here because a times x. So whatever the magnitude of the branch will be, that will get multiplied with the variable, okay, on this side. So a multiplied by x will give you y. So this y is equal to ax is represented like this. So from this equation, it is very clear that every variable in a signal flow graph will be designated by a node. Will be designated by a node. So definitely you ask, so how many nodes will be there in a signal flow graph? The number of the nodes will be equal to the number of the variables involved in making that system. Okay. Okay, now each node is connected by another node. Every transmission function in a signal flow graph is designed by a branch. So how the signal is transmitting, so this is being represented by a straight line. So this straight line is in fact a branch. This straight line is a branch, and each branch is associated with the arrow sign, either on this direction, okay, or on this direction according to the equation which is representing the system. So node is clear. Branch is nothing but the transmission link with the arrow sign. One important thing, branches are unidirectional. Unidirectional means you cannot have, like for example, this branch, two arrow cannot be there in a branch. This is a wrong. Okay, either it will have this feed forward or it will have like this backward. Okay, feedback signal. There cannot be two arrows in a single branch. So it is a unidirectional in nature. In scientific terminology, I will say that branch is in unidirectional form. The arrow in the branch denotes the direction of the signal. That I have already told you, that arrow is being marked, and that arrow will indicate that what is the direction of the signal. Okay, so if it is moving from x to y, it means it is a forward direction. If it is moving from like this, then it will represent that it is a backward or feedback form. Okay, so this is clear, I think so. Now the nodes have been also being classified. The path, the transmission line is also being link has also been classified. So let us look towards it, how they have been classified. So first of all, node is clear. Node is representing the variable. Now node can be of different type. There can be input node, there can be output node, and there can be a sync node. Okay, so input node, what is the input node? What is the input node? Input node, also known as the source node, okay, contains only outgoing branches. Okay, means something is going out from it, then it is called outgoing. So like this, in this signal flow graph which you are seeing at the bottom, what I am seeing, that there is a signal x1 is there. Okay, there is, sorry, variable x1 is there, variable x2 is there, variable x3 is there, x4 is there, and that is why you have 4 nodes there. So 4 nodes, 4 variables, very clear. Okay, now you can see it looks towards x1. In x1 there is only outgoing branch that is moving towards x2. So x1 is known as input node. X1 is your input node. Okay, what is the output node? Also known as sink node. Okay, so input node is also known as source node, and output node is known as the what is the first of all output node? An output node, also known as sink node, contain all incoming branches. For example, x4. For example, the x4. In x4, what happens? This signal is coming from x3, another signal is coming from x2. So only incoming branches are there. So your x4 is an output node. So x4 is an output node. Is it clear or not? Yes, Sanjay Prajapati, do you want to ask anything about x1? You have written x1. What does this mean? Yes. Clear? Okay. So input node is clear, which has only, mind it, the word only is written. Only outgoing branches. Output node, which has an only, which is also known as sink node. Okay, which has only incoming branches. Okay. Then there are mixed nodes also there, like x2. It has an incoming also, and there is an outgoing also. There is like this x3. It has incoming also and outgoing also. These are called mixed node because they have both type of signals. Okay. Then what is the path? Next come the path. So path is a continuous unidirectional succession of branches along which no node is passed more than one. So if I say trace out the path, okay. So if I say trace out the path, then what will you? If I say trace out the path, so how will you find out path? Okay. So you have to keep in mind that continuous. It should be continuous. There should be no discontinuities there. It should not be bidirectional. Okay, that is, it will choose only one direction, that is from either from input to output or from output to input. Okay, it is not that you are just from input, then again going from going towards output, then again move towards the input side. No, it is not there. It is always unidirectional. Unidirectional succession of branches. Okay, the branches should be in a succession. Okay, that one after another. You not that from x1 you are directly jumping to x4. Okay, you say it is also path. I am jumping. I am, so no, jumping is not allowed. It should be in succession. This branch, like this branch, and like this. So this can be in path. What is next definition? Along which no node is passed more than once. Okay, so it is not like that. Suppose you are passing from x1, x2, x3, and then you're passing, sir, I will move like this. No. Why? Because x2 has been traced twice. X2 has been traced twice. So no node is being traced twice. This you have to be keep in mind. Is it clear or not? That while finding out the path, okay, the path will be also two types, forward path and feedback path. But definition of path is that there should be no node should be traced twice. It should be continuous and it should be consisting of unidirectional successive branches. Is there any problem? If problem, then please ask me. I'm not getting any reply from anybody. Okay, so from x1, let us find out the different path: x1, x2, x3, x4. So it is a continuous path, unidirectional, in the same direction. Okay, in the same direction, and also what you are finding that there is no node is traced twice. So one path is x1 to x2, x2 to x3, x2 to x4, like this. Is it clear? Another path. Okay, so this x4 should be here like this. So there was a little confusion there. Next is from x1 to x2. Okay, and then I am moving like this, x4. This is another path. Okay, Again, no node is traced twice. Okay, continuation is there, unidirectional succession of branches is there, and no node is traced twice. So it is also one path. This from this to this, input to output. Another path. Okay, you are moving from x2, okay, then x3, then x4. But it is not from input to output. Just from middle you have taken it. So this type of path is just not of much use. Okay, we are generally being useful from input to output. That is called feed forward path. Okay, so this path has been classified into two forms: forward path and feedback path. So what is a forward path? A forward path is the path from input node to the output node. Okay, this is your input node and this is your output node. So how many forward paths are there? Forward means you are not looking in a feedback form. You are just moving straight forward. Okay, so you are moving from input to output. That path will be considered a forward path. So let us find out how many forward paths are from x1, x2, then x4. This is one path. This I have shown here. Another x1, x2, x3, x4. This is the second path. So there are two forward paths there. Mind it. Don't take it this concept as an easy going concept. They are easy, but don't take it in a just casual manner. Okay, because when we'll use the formula called Mason-Gain formula, you have to identify only these only: forward path, feedback path, loop, and everything. So that will be useful in a formula called Mason-Gain formula, through which you can find out the transfer function of the system. So that is why I am stressing on these terms, that is node, path, forward path. So for up to forward path, I think so it is clear. Or if there is any doubt, then you can just ask me by writing in the chat box. Only one student is writing no, sir. Rest all students are sleeping or what? Please, if you are going through chat box, it means it is very clear that yes, you are active. Okay, so after forward path, the next is your the feedback path. Okay, so let us discuss what a feedback path is there. So basically, feedback path is also known as loop or feedback loop or simply loop. Okay, some book write loop only. Okay, so what is a loop is there? So loop is a path which originates and terminates on the same node. Mind it. So loop is different and forward path is different. Loop is also known as feedback path. So in Mason-Gain formula, you have to identify both forward path as well as the loops. Okay. So loop is also known as feedback path. So in this, it is a closed path. So a feedback loop is a closed path which originate and terminate on the same node. So let us find out how many loops are there in this example signal flow graph. You can see this is x2. Okay, I am moving from x2, then moving from x3. Okay, then there is I am again traversing back. A feedback signal is there, and again reaching to the node x2. So this is an again loop. This is again a loop from x1 to x. Sorry, from x2 to x3 and back to x2 like this. This is again loop. Now, can you identify there is another loop? Can anybody can identify another loop that is known as self loop? Okay, so this was the loop starting from x2 moving to x3 and then back to x2 through a23. So this is a loop. There is a self loop is there. This is okay. It is starting from x3. Okay, moving like this and then again terminating coming to the x3 without passing through any another node. So this is also loop, and this loop is known as self loop. So don't get I haven't written it here, but this is known as self loop. Okay, so because it is forming a closed path and it is terminating at the same node from where it has started. Is it clear or not? If any doubt? Yes, at x3, very correct, at x3. Okay, Yes, this only, this only. This is known as self loop. This is also known as self loop. Okay, while these are the feedback loop, this is known as self loop. So when we identify loops, we identify self loop also. It is not that we can only apply to this feedback loop only. We identify the self loop also. Any problem? Any doubt? So Anna, I have given you a definition. Okay, so what a self loop is there? It is a feedback loop consisting of a single branch, that is A33. In this case, you can see A33 is the self loop. Okay, now another terminology is your gain. Okay, so it is in fact the transmission function of that branch. For example, this is a branch which is connecting x1 and x2. So A21, it is the signal strength. It is known as the gain. The signal strength of a branch is known as the gain of that branch. So A21 is the gain of this branch. What is the gain of branch moving from x2 to x3? Please write down in the chat box. What is the gain of branch moving from x2 towards x3? Please write down. Yeah, somebody, Alisha, correct. Alisha is written correct. Eva has written correct. Jagdish Megwal is correct. Sudhanshu, Sresh Bora, yes. Lalita Vishnoi, yes. So most of them got the point. Yes, you are very correct. The correct answer is A32. Similarly, the gain of this branch moving from x3 to x4 is A43. Branch x2 to x4 is A42. Gain of this is A33. Of this self loop is how much? A33. So like this way, you have to identify their gain also. Okay, now path gain. Another word is there after gain. The word is path gain. So it is nothing but the product of the branch gain encountered in traversing a path. Okay. Okay. So you are traversing a path, for example, forward path from x1 to x4. So how much branches you are? 1, 2, 3 branches you are traversing. Okay. So what is the gain of first branch? A21. What is the branch of A32? And what is the gain of this branch? Okay, third one, A43. So what will be the net gain? So net gain is also known as the path gain. The path gain is nothing but the product of these three gains. Okay, so the path gain of this path will be A21 multiplied by A32 multiplied by A4. Okay, so this is the path gain of A21, A32, and A43. Is it clear? Similarly, if I ask you what will be the path gain of a branch of a path moving from x1 and reaching to x4 through x2. Okay, so this what will be the path gain of this path? Can anybody can tell me? Write down in the chat box. Yes, here we are considering only forward path. Okay, there will be a gain, loop gain also, that will be called as a loop gain. If we consider loop also, that will be called as the next term is loop gain. So at present, the path gain word is used only, forward path gain is used for the forward path only. So A21, A42, very correct, very correct. Most of the rare has written very correct. A21 and A42, very good. Okay. So two forward paths were there and we have already written their path gain. Now next come the loop gain. Loop gain is the product of the branch gain of the loop. So you have to, as I've already told you, two paths are there. One is forward path, another is feedback path, also known as the loop. Okay, so we have already find out the path gain. Now we find out the loop gain. So there are two loops are there. One is this one. So Again, the same, you have to take the product of all the branches, gains of all the branches, which has come in between that loop. So this was one loop. You can see this was one loop. Okay. How much gain is A32 multiplied by A23. So this is the loop gain of this loop. Now, what is the loop gain of this self loop? Can anybody can tell me? Sorry. So can anybody can tell me what is the A33? Very good. So the loop gain of self loop is the only the gain associated with that branch only. So A33 is the loop gain of this self loop emerging from X3 and terminating X3 only. So it is very clear how to find out the path gain or the forward path gain. Okay, forward gain also known as forward gain, forward path gain, whatever term you can use. And the second is the loop gain, which is nothing but the product of the branches or branch gains of the loop. Now, another term is being used, non-touching. Touch means very clear, chuna. In Hindi, it is a chuna. Okay. So, non-touching simply means that the loops are not touching to each other. Loops. So, this word path or for loop or which are not touching to each other. For example, let's talk about these two loops. This is one loop and this is second loop. Are they touching each other? Are they touching each other? Are loop 1 and loop 2 are touching each other? Yes, they are touching each other. So they are not considered in the non-touching loops. Okay. Suppose I draw a loop here, self loop. Okay. Now tell me whether this self loop and this self loop are touching or non-touching. Non-touching. Very good. Very good. Similarly, tell me this loop and this loop. Let's say this is L1. Let's say this is L2. And let's say this is L3. Okay. So what you will say about L1 and L3? Are they touching or non-touching? L1 and L3. Non-touching. Very good. Very good. Very good. Very correct. And similarly, L2 and L3 are also non-touching. So it is very clear. So now these all I am telling you, not just that these are very simple, but these are all will be useful in our so-called the Mason gain formula, which is the base of the signal flow graph. So today we have learned a lot. A node we have learned about the branch. We have learned the branch gain. Then we have got a path gain. Then we have learned about the forward path. Then we have also the feedback path, also loop. Then the loop gain also. Then we have talked about the non-touching loops also. Okay. And similarly, there are non-touching paths are also there. If the path are not touching, for example, this path is not touching this loop. Okay. So this you can easily infer, because if no node is being touched, then it is a non-touching path or non-touching loop. So I am not ending here. So I am not ending here. I am still working. I was just revising it. So don't take it that I am ending here. Still time is there. So now in this slide, what I did is that now I have represented everything is there. Okay. So what this is node is called? This is the input node, because only incoming branches are there. Okay. So sorry. Okay. Sorry, this is what is this? This is a mixed node, in the sense incoming branch is also there and outgoing branch is also there. This is your, yes, I will give you the Google Classroom code. Okay, today I will try to give you. Okay, this X3 is called the output node. This is called the output node. Similarly, X4 is also input node. See here in this diagram. Okay, and what is the gain of this X1 to X2? This is basically X2. Okay, it is A. What is the gain from x2 to x3? It is b. What is gain from x3 to this is also being unity path, so it is also x3. If you can mark it x5 also, so it is unity. It is unity only. Okay. So transmittance is b. It is also gain is also being referred as transmittance. So you need not have to confuse. Okay, transmittance and gain is the same thing. Okay, some people use transmission. This is branch. Okay, branch gain is this b or a or 1, or you have to identify input node is clear, also known as source node. Output node is also clear. It is known as sync node. In between the mix node is there. So everything has been represented. All the terms have been represented here in this. So let us now, after going through this all these terms, basic fundamentals, let us draw a signal flow graph of representing by the following equation. This is an algebraic equation. Do you agree? Transmittance is the another name for gain. Yes, slash transmission is the another word for gain. Okay, instead of transmittance, you can use gain also, or you can use the transmittance of the following branch is B. The transmittance of the following branch is unity. The transmittance of this forward path, this branch is A, or you can use the gain of this. The same thing is there. Yes. So now I am taking an example. Okay, this example will elaborate how to draw a signal flow graph from an equation. How many equations you are seeing? 4 equations. How many variables? Everybody should write. How many variables are there in this? How many variables? Please write down in the chat box how many variables you are seeing in this equations. Go through these equations. I have write down 4 equations. Okay. Somebody is written. Okay, I could not understand how somebody has written 8. Lalita Vishnu has written 8. No. Pranajay Singh 5. Sudhanshu 4. Okay, please go through it. Are you correct? Sanjay Prajapat 5. Very good. Tanmay Mishra 5. Alisha 8. Who has written? Another person has written 8. 5, 5, 5, 5, 5, 5, 5, 5. Yes, those who have written 5, 4 is wrong. Sachin Singh. No, sorry, Jagdish Meghwal, you have Sachin correct. 5, Jagdish Meghwal 4 wrong. Lokesh 5. Harshita Dalawat, okay. Kajal Kawar, no, it is 5 is their answer. Okay, yes, you have corrected. Amit Paliwal 5. Okay, fine, fine. Harshil 5, 5. Yes. So there are 5 variables are there. See, there x0 is also there. X0, x1, x2, x3, and x4. So how many variables are there? 5 variables are there. Okay. So what you will do? Okay. Now since the variables are being in the form, so you will form 5 nodes. 1, 2, 3, 4, and this is 5. So 5 nodes are clear, I think so. Now let us work on the first equation. Okay. Now while writing down the branches and all this, making branches on the signal flow graph, always you have to keep that when I say x1 is equal to this much, then it will have only incoming branches. This equation is representing that incoming branches only. So this is my x0. This is my x1, this is my x2, this is my x3, and this is my x4. No doubt the answer is in front of you, but how we have arrived to this answer, that is very important. So let us focus on the first equation. X1 is how much? A times x0. X0 is this much, so I will draw a branch here. So this equation is representing only incoming branches towards x1. So x1 with branch gain A. Clear? Next is plus bx1. So another branch, incoming branch is there who is coming from x1 itself only and have a magnitude b. So it is forming a basically self loop like this with this arrow sign. And how much is the value of this? This value is b. Then cx2. So an incoming branch is coming from x2 with magnitude with n equal to c. So it will be like this. C arrow in this direction. So it will create a problem in the, so what I will do, because it is coming in the feedback form, mind it, it is coming in the feedback form, okay, because we have to travel in the backward form, so I will represent like this. So how much it is representing? C. So the gain is C. It is clear. Now next come to the second equation. It is equal, it is representing that what should be the value of x2. So again, all the things will be on the other side, will be incoming branches, that is dx1. So one signal is coming from in a forward way, so dx1. So this will be d. Another is coming from x3. So it is again in a reverse form. Okay. So what I will do, magnitude is e. So I will put it here like this. Let's use e. So here it is being so downward. Either you can draw downward or upward. It depends upon you. You did not have to convert. Now next is your x3. What is the value? X3 again, incoming branch is fx0. So another branch is coming from here. See, okay, from x0. So it is not that like you will draw like this, because it is represented like this. So you will just move like this. This is coming, and magnitude is how much? F. Its gain is how much? Equal to F. Okay, plus gx2, plus gx2. So where is x2? X2 is here. Okay, it is the forward path is there. Therefore, G, this is, I am this. So mark its gain as a G. Okay, so now next is how much? X4. X4 is how much? At X3. So simple, a line is there. In this way, the whole signal flow graph is ready for the following four equations containing 5 variables. I think so. The signal flow, and the answer, the more in a correct, more in a beautiful form, the answer is this much. This and this two same are the same diagram. If anybody is any confusion in this regard, please let me know through the chat box. अगर किसी को कोई समस्या आए वो चैट बॉक्स में लिखे, मैं आपको अभी बताने को तैयार हूं. अगर ये समझ में नहीं आया तो वेरी डिफिकल्ट फॉर यू टू अंडरस्टैंड द सिग्नल फ्लो ग्राफ. Lalita Vishnu, no problem. Shreyash, no problem. Okay, anybody has any problem, then just write down. Okay, sir, I could not understand. There is no need of hesitation. You can freely ask me. I am ready to reply you. Okay, and especially on this Teachers' Day. Please write in the chat box. Yes, clear, clear. Okay, clear. No, okay. Ek bar or okay, sir. Okay. One student has once more. Okay. So please pay attention. Okay. Once more, I am repeating for self loop is a feedback. Self loop is a feedback. Yes, that I will tell, non-touching and everything I will tell you. So first of all, I will tell you that how to write down how to draw the signal flow graph. You have to identify how many variables are there. So here we are, by looking towards x1, x0, x1, x2, x3, and x4, we have found out that there are 5 variables are there. So I have drawn 5 nodes. Okay. Then I have taken one equation, each equation one by one. First of all, this equation. Now this is representing x1. So all the other terms are in fact the incoming branches. There will be no outgoing branches will be there while representing an equation. So x1 is equal to this much, means these are all our incoming branches. So one branch is coming from x0 multiplied by a. So I have drawn this branch from x0 to x1 with magnitude equal to gain equal to a. So this is added bx1. Okay, so bx1 means bx1 means a self loop. Okay, because I am representing x1 only. So a self loop I have drawn it. Okay, its magnitude is equal to how much b. Similarly, cx2 is nothing but an a feedback, again a loop in a feedback form it is coming. So I'm not drawing in a straight way, but I am drawing in this loop form. So whose magnitude is c. So in this way, first equation is ready. Similarly for x2, again how much? Dx1. So coming from dx1 means from x1. This is x1. So this is being connected d ex3. Where is e? Ex3. Ex3 means coming from here. So this is like coming in the feedback form. Then we have to write down x3. X3 is nothing but fx0. So it is coming from here. Okay, this big loop. This magnitude is gain is f plus gx2. So g is coming from x2. So simply a forward path. X4 is hx3. So h multiplied by this, and in this way you are complete. Now non-touching loop. Very good question from Prananjay Singh. Okay. Now you can see here. First of all, identify how many loops, how many forward paths are there. Tell me. Anybody can tell me how many forward paths are there in this signal flow graph? There are two forward paths there. There are how many forward paths? There are two forward paths is there. Okay. How much? This is the first forward path moving from input to output. A, this D, moving from x2 to x1, x1 to x2, x2 to x3, and x3 to x4. This is a forward path. Another forward path, x0 moving through x through and then x4. So two forward paths are there. Okay, it is very clear, I think so. Now next come the loops. How many loops you are seeing here? Can anybody can tell me? X0 to x3. Yeah, that I have already told you na. X0 to x3 and then x4. This is another path. How many loops are there? Yes, please see. Forward path. Forward path means moving from input to output. So I am moving from x0 to x1, then to x2, then to x3 and to x4. It is a continuous successive branches are being no node is traverse path. So this is the first forward path from x0, x1, x2, x3, x4. Another forward path starting from x0, going like this. Look towards my arrow. Okay, going. Oh, sorry. Going like this, going like this, going like this, coming to x3 and then from x3 to x4. This is the second forward path. Okay, so there are two forward paths are there. Okay, and how many loops? Somebody say 3. Amit Paliwal saying say 4. 4. 3. Sachin Singh says 3. Okay, so let us find out the loops. See, look toward the first self loop. Okay, starting from this node, going through this. Okay, this is one loop. Another starting from x2, starting like this, going to x3. Okay, moving through this feedback path and coming to x2, second loop. So this is your first, this is your second. Okay, and now another loop starting from here like this, starting from here like this, and this is your third loop. Okay, so Shresh Vora is saying fourth one. Can anybody can tell me how it is fourth one? From x0 to x3. So he's saying that you go from like this as the forward path. Okay, then coming to this at this node will be traversed twice. Okay, you say like this path, x0 to x3 like this. Okay, then where should I move like? Okay, then suppose I move like this, move like this, move like this, then move like this, move like this. Okay, then where? Then where? Then where can anybody? Path is not a closed path. End point and beginning point and are not terminating each other. Okay, so it is clear. How many paths are there? There are 3 loops are there. Now, Prananjay has asked me, sir, how many are the non-touching loops? Okay, so this was the first one. This was the second one, say. and this is also the third one. So if first and second are touching, yes, they are touching. If first and third are touching, no. First and third are not touching at all. So first and third are one pair of non-touching loop. Okay. So first and third are is a one pair of non-touching loop. No, not touching means non-touching loops. So one pair is 1 comma 3. Another is 2 and 3 are touching. Yes, 2 and 3 are touching. So there's no other combination is there. Okay, because ultimately in Mason-Gann formula you have to find out the pairs, okay, which are not touching. Okay, so here only one pair is there, one loop is there, only one loop pair is there which is non-touching, that is 1 and 3. And now you can find out the, if I ask you the forward path gain of first forward path, how much it will be there? A multiplied by D multiplied by G multiplied by H. So the loop gain of the first forward path, let's say it is F1, so it will be nothing but A, D, G and H. What is the loop gain of second forward, sorry, the path gain of second forward path? It is F multiplied by H. Very good, very good. FH. Okay, similarly, you can find out the loop gain also. Loop gain of first loop is nothing but L1 will be equal to how much? P. What will be the loop gain of L2? L2 will be nothing but D multiplied by C. So DC. What will be the loop gain of L3? G multiplied by E. So it will be G E. Now, if I ask you the gain product of the two non-touching loops, there is another word called gain product. So these 1 and 3 are the one pair which is becoming non-touching. So its product will be equal to how much? What is the loop gain of 1? B. What is the loop gain of 3? G. Okay, so the gain product will be B, G, E for this pair, for this non-touching pair, BEG. I think so it is clear. BG or BEG, whatever you write down. Okay, I think so it is clear or not. If clear, then please write down yes sir, clear. And if any doubt, then you can write down that doubt. So thank you very much. Today I am ending here. So you revise it, and all these videos are available on YouTube. Mind it is live session also. Live streaming is being also going on. Now this live streaming is for those who do not belong to CTA. Okay. So if you have any friend is interested in attending the class, then you can share my channel Gyan_hub. Okay, there every day, whatever lecture of circuit theory or control system I take, it is always being live streamed. So these people can go through their YouTube videos, and moreover, you can also these videos are available after the class is over also. So if you have any doubt, you can go through my that videos also. And I always want that I want certain comments in the comments box if you have any doubt. Okay, because doubt is always there. It is not that everything is clear in the first shot only. So doubt is always there. Please do write your doubt in the comment box. I will be happy to respond to your doubts. Okay, so Shreyash Bara has a doubt. Yes, please write what doubt you have. Okay, no doubt. So everything is there on YouTube. It is live stream for those in the counting of loop. Can we count a node twice or more time? No, no, no. I've already told you in the forward path as well as in the loop, you cannot traverse a loop twice. You cannot traverse a node twice. Yes, this you have to keep in mind very importantly. Okay, so whether the forward path or in the loop also, you traverse the node twice. If you are traversing the node twice, then it is not a forward path, it is not a loop. Okay, is this clear or not? Everybody has to pay attention to this important point that in a loop, in a forward path, no node is traced twice. If you are tracing it twice, then it will not be a loop or forward path. Is it clear? So once again, thank you very much for giving a compliment on the Happy Teachers Day. So on this Teachers Day also, we have engaged the class. This was really a very wonderful session. Okay, I will remember. Thank you very much.